Okay. Permutations and factorial notation. Okay, so arranging objects. How many arrangements can 6 children form when they're lining up to get a drink? Okay, so 1, 2, 3, 4, 5, 6. I have 6 kids. They're trying to get themselves in a line. So here's what I'm going to start with. How many options for children do I have to put somebody in the start of the line? I can put 6 different children there. Okay, and then I'm going to go to the next spot in the line. How many options of children do I have for the second spot? 5, and then you see what I'm doing? 4, 3, 2, and then I only have 1 option when I get to the end. Okay, I'm not going to multiply that all out because there's a shortcut. In math, this is what we call 6 factorial. Okay, everybody has a button on their calculator. I know we have these big fancy calculators now. I actually prefer not to use this calculator for this unit because it's a little bit harder. Like, it's not harder, but it takes more buttons. I will show you. So if I'm on this big fancy calculator, I'm going to push 6. Then I'm going to go to this button called Math. And then at the end here, this is called Probability. Math Probability, and then you can see that exclamation point. And so it's 720. There's 720 ways I can line up my kids. So for me, I prefer my normal calculator. Okay, I'm just going to pause this and make sure everybody found their button. Okay, so obviously you can see that the orders go down by 1. So in this context, if I do an n factorial n, and then the next lower would be n subtract 1, n subtract 2, n subtract 3, da 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 da. No matter what you do, it always stops at the value 1. There's always just 1 option in your last spot. Okay, so I'm going to get you to try this one on your calculator, 10 factorial. So see if you can type that. Finding your button. It'll be big. Everyone's good? Found their button on that one? Okay, next, I'm going to start expanding, and we're going to stop to simplify. So I'm going to start by expanding 12 factorial. So 12 factorial. So what comes after 12? 11, 10, 9, etc., etc., etc. And I stopped there on purpose. Okay, why do you think I stopped there? Because the 987654321 will cancel. All of that would cancel with the 987654321. And then I guess I better expand that out because it doesn't cancel with anything right now. So that's a 321. So now you can just calculate however you want there in your calculator. After you got rid of those, give me 12 times 11 times 10, and here you would have 3 factorial. Okay, next one, simplify. So if this is n plus 3, and then the next says n plus 2, and then from there it says to go down, 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 down. Would this not be okay to write? Why don't we just start like that? Because we went down, and then down, 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 so we could just start with the n plus 3, and that includes everything lower than that. Okay. Which one of these values is larger? You always start expanding the one that's larger. Which one of these is a larger value? N plus 1 or n minus 1? Which value would be bigger? N plus 1 is a larger number. So for instance, if n was something like 10, this would have been an 11 and this would have been a 9. Okay, so n plus 1. We're going to go down. Expanding means go down. So what's 1 lower than n plus 1? Just an n. What's 1 lower than n? N minus 1. And I'm going to, etc., 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 go down, down, down from there. Because on the bottom, that's where I stopped. So everything from that point on would cancel. How do you simplify something like this in math? These are being multiplied by each other. So how do I multiply that? Simplifying means multiply it. So then I would get, you have to expand n squared plus n. Okay, okay, this next one, I'm going to show you the pre-calcy way, and then I would probably show you somebody who's going to do it an applied way, and you can pick which way your brain wants to go. Okay, pre-calcy way. Which one of these numbers is a bigger number, and I would expand. So n is bigger than n minus 2. So n, go down 1, n minus 1, go down 1, okay, that's the expansion. Then I see those factorials cancel. This makes n squared minus n. Then I would move the 90 over to zero out my equation. So this is very pre-calcy here. And then you did this skill. Everybody has done this skill. I need to factor that. Somewhere along the line, you remember that skill. Some of you haven't done it for a while. N times n. What times what makes 90 and adds to the middle of negative 1? 10 times 9. I need one of them to be negative, one to be positive, and I'm trying to make it add to negative 1. N equals 10. n equals -9, which that one doesn't make sense because you have to stop. Okay, applied, you could have just kind of done a guess and check. So something like n factorial and then 2 lower factorial. Like I could have started just guessing. I could have tried that in my calculator. 14 factorial divided by 12 factorial, 182. So I'm too big. No. So if I'm too big, I would go down and I could have done, 13 factorial divided by 11 factorial. Okay, I could have tried until I figured it out. No. So finally, I could have done that and it would have worked. So n was 10. Okay. Or I feel like this would have been a really good place to think about your mental math skills. Once we canceled that out, we had a number times one number that's lower than it, making 90. So can you think of 2 consecutive numbers that multiply to 90? 9 times 10. Okay, so maybe you could have thought, can you grab that for me? Okay, that for me, if I'm trying to juggle the applied brain and the pre-calc kind of together, this is probably what I would have done with, and just thought, well, what are 2 consecutive numbers that multiply to 90? And then I can use my mental math thinking process. All right, that's it.